Chapter 7, Section 3. This section covers a very important law and a theorem to understand statistical hypothesis testing. Law of large numbers and a central limit theorem. Suppose there are two hospitals of obstetrics and gynecology in our town. Hospital A is large and Hospital B is small. On average, 100 babies are born in Hospital A and 10 babies are born in Hospital B. In this case, which hospital has the higher probability that 60% of newborn babies are male? Let's see a simpler example. Suppose we will implement two experiments. Experiment C is throwing a die 100 times. Experiment D is throwing a die 10 times. In this case, which experiment has the higher possibility that 60% of the pips are odd numbers? The right answer of the second question is experiment D. And the right answer of the first question is Hospital B. These problems can be explained by the law of large numbers. The law of large numbers states that as the sample size grows, the sample mean approaches the population mean. In the dice throwing experiment, on average, the probability of getting an odd number is 0.5. In this experiment, the number of trial, that is, the number of throw, is the sample size. This line plot is the simulation results that shows the probability of getting an odd number for each number of trials. As shown in this plot, as the number of trials increase, the probability approaches 0.5. That is, the sample mean approaches the population mean. So, as the sample size increases, the representativeness of the sample increases, and thus, the inference based on the sample becomes more robust. That is, as the sample size increases, we can make more robust inference of the population parameters using the sample statistics. Let's recap the use of term, sample size and the number of samples. Sample size means the number of observations contained in a subset. The number of samples is the number of subsets extracted from the population. This use of term is important to understand the central limit theorem. Let's see a very important theorem to understand statistical hypothesis testing, central limit theorem. Central limit theorem states that if we take samples from a population with replacement and the population mean equals mu and its variance equals sigma squared, as the sample size grows, the distribution of the sample mean approaches to a normal distribution with the mean equals mu and a variance equals sigma squared divided by n. The denominator n is the sample size, so it means that as the sample size grows, the variance of the sample mean gets smaller and concentrates around the population mean. So we can say that according to the central limit theorem, as the sample size grows, we can make more robust inference about the population mean from the sample mean. The central limit theorem holds regardless of whether the population follows a normal distribution or not. This is a notable strength of the central limit theorem. It means that by increasing the sample size, we can make robust inference even if the population does not follow a normal distribution. When the sample size grows to more than 30, the theorem holds well. And if the population follows a normal distribution, the theorem holds even when the sample size is smaller than 30. Let's understand the central limit theorem by using an example of rolling 6-sided dice. The population mean of pips is 3.5. Here, we roll multiple dice and calculate the average. The average is the sample mean. the number of dice we roll in one trial is a sample size. And we implement this trial multiple times. The number of times we implement this trial is the number of samples. This histogram shows the result of dice rolling simulation. In every case, the number of trials is 1000. So the number of samples is constant. The upper left histogram shows the result of rolling 2 dice in a trial. So the sample size is 2. The sample means are widely dispersed. The upper right histogram shows a case of 10 dice trial. The sample mean distribution approached a normal distribution and converged to a bit to 3.5, the population mean. The lower left histogram shows a case of 30 dice trial. The sample mean distribution further converged. The lower right histogram shows a case of 100 trial. As we can see, as we increase the sample size, the sample mean distribution approaches a normal distribution and converges to the population mean. Thank you for watching. Please thumbs up and subscribe to my channel.